Hello guys, trust you're doing fantastic. Now welcome to another interesting topic, which is the BCP, known as the binary coded Pentary. Now you may be wondering, what is this all about? Now it's nothing but a new binary coded Pentary number system which is proposed, in which every digit of a base 5 number is represented by its corresponding 3-bit binary code. Now let's take an example for you to understand this more. 24 in base 5 will be represented by its BCP code of 010100 in this numbering system. Now this is the BCP code to represent 24 in base 5. Alright, so let me take a step further to explain something. Now let's note this. Now the BCP of base 5 number of 24 is represented by the BCP code, which is 010101. Now for you to understand this better, you need to understand that the base 5 number system is represented by its corresponding 3-bit binary code. Now since we're going to be using 3-bit, it means this is the maximum number of bits that can represent a digit in base 5. Now since we're going to be using 3-bit binary code, it means we're going to be using this formula, which is 2 raised to the power of 2, 2 raised to the power of 1, 2 raised to the power of 0. Now 2 raised to the power of 2 is going to give us 4, 2 raised to the power of 1 is going to give us 2, and 2 raised to the power of 0 is going to give us 1. So this is the code we're going to use in order to decode or represent base 5 number system in their corresponding BCP code. Now since we understand this formula, all we need to do is, once you have this code and we need to represent this code in base 5 number system, so we need to group them in threes. Since we're using 3-bit binary code, so we're going to represent them in 3 bits. So it means we're going to group them in threes. In that case, when you have a BCP code 010100, all you need to do is to group. You start from the left hand side and group in the direction of the right hand side. So what we'll do first is we count 1, 2, 3, ensuring that you have 3 digits in a group. So we underline it. Alright, so once you underline it, now using this formula, it means that the first bit from the left is 0. Okay, it means that 4 is absent. Now the middle bit has 1, it means 2 is present. And then the third bit has 0, it means 1 is absent. It means in this case, this bit 010 represent 2. It means 2 is present. Now go to the second group, which has 100. So this is a group of 3 bits. All we need to do is to compare with this formula. We have this formula as a guide. Now the first digit from the right has 1. So it means that when you look at this formula, it means 4 is present. So it means we have 4. And then you have the middle bit and the third bit, you have 00. It means 2 and 1 is absent. So in that case, you have 4. So that is how we derive the value 4 and how we derive the value 2 on the first group. So it means that the BCP code 010100 is equal to 24 in base 5. So that is what it means. So let's go a bit deeper. Let's see what we can do. So in this case, let's consider a second example. Now we have this with this question says if we have a BCP code of 100010011001, what is its equivalent in base 5? Now we need to convert the BCP code to base 5, the equivalent. Now this is a solution. All you need to realize first is, since it's 3-bit binary code, it means we have to use this formula, which is 421. I explained to you how we got this formula, right? So that's very, very easy. All right, so the next thing we need to do is to write out this BCP code we have here, and then we need to start grouping. That's the first thing you do. So we group from left to right. Ensure that each group has not more than 3 bits. It means you must have 3 bits, and it shouldn't be less than 3 bits, and it shouldn't be more than 3 bits. It should be exactly 3 bits. So when grouping from left to right, we count 1 2 3, we put them in one group. We count 1 2 3, we put them in another group. 1 2 3, put in another group. 1 2 3 in another group. So we have 1 2 3 4, we have 4 groups in all. So let's start decoding this group and start representing them in digits. Since we know the formula, which is 421, so let's check the first group. The first digit has 1, it means 4 is present, and then the rest of the digit, which is 00, it means 2 and 1 is absent. So in that case we have 4, so this represents 4. For the other group, we have the first digit is 0, it means 4 is absent. The second digit is 1, 2 is present. Then the third digit is 0, it means 1 is absent, so we have just 2. So this code represents 2. And then for the third group, we have the first digit 0, meaning 4 is absent, and then we have the second digit 1, and the third digit is 1, it means 2 and 1 is present. In that case, if you sum them up together, 2 plus 1, you're going to get 3. Now for the fourth group, you have 0 0 1. The first digit 0, meaning 4 is absent. The second digit is 0, meaning 2 is absent, and then the third digit is 1, meaning 1 is present. So in that case, this is going to be decoded as 1, so it represents 1. So in that case, the digit in base 5 is going to be 4231 base 5. So that is how we derive this value, 4231 base 5. So this is how simple it is for you to represent a digit in base 5 to BCP, or BCP code represented in base 5. So this is how simple it is for you to work this out. Very easy. So thank you for watching this video, and pay attention to the subsequent video in this channel. All right then, enjoy this video. Bye.